Welcome back. This is types of probabilities. So I please request you all to have your pen and paper ready so we can go ahead and do the problems. So this is a continuation of the previous topic. So please, if you did not watch that video, I highly recommend you all to watch it so you all can follow along. So let's go ahead and jump right into our problems. So today's section is going to be make and test predictions using empirical probability models. Remember, empirical is I collect all the information, and based on that, I use frequencies, I use counting, and based on that, I go ahead and find the probability. Empirical probability is also referred to as relative frequency sometimes. So let's go ahead and take a look. You flip a coin 16 times and get 7 heads. What I'm going to do is I'm going to go ahead and highlight the numbers or the terms. Where is it? I'm going to use this color. I'm going to go ahead and highlight the numbers that are important to us. So I'm flipping a coin how many times? 16 times. How many heads did I get? 7 heads. I get heads 7 times. Based on this experiment, what is the probability of flipping a coin and getting tails? So look what they're asking you for. You're flipping a coin 16 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Hopefully I have 16 there. 7 of them are heads. So from 16 coins, if 7 of them are heads, how many of them are tails? 16 minus 7, which is 9. Okay? All right. So 9 of them are heads out of your 16 flips. So you flip them 16 times. So 7 of them are heads, the remaining have to be your tails. So 9 of them are your tails. What are they asking me? What's the probability of flipping a coin and getting a tail? Remember how we work our probability. You always start with your sample space, that is your fraction, right? Probability of this event E. I start with my fraction. What's my sample space? I'm flipping a coin 16 times, so 16 is my sample space. How many tails do I have? 7 of them are heads, so by default, 9 are my tails. So my option is 9 out of 16. All right, let's go ahead and take a look at the next one. You flip a coin 10 times and get 6 heads. You're flipping it 10 times and you get 6 heads. Based on the experiment, what's the probability of flipping a coin and getting a head? As simple as that. You flip a coin 10 times, so your sample size is 10. You have 6 heads, so 6 out of 10. I don't think they are reducing it, so keep it as an unreduced fraction until or unless they specify or ask you to reduce it. All right, let's go ahead and take a look at the next one. Probability that Gail is on time for a given class is 69%. So Gail comes to class only 69%. So out of 100 times the class happens, she only comes to class 69% of the time. If there are 38 classes during the semester, what is the best estimate of the number of times out of 38 that Gail is on time to class? Round your answer to the nearest integer because we can't say she comes to class 12 and a half times, right? That's not possible. So Gail comes to class 69% of the time. But that she attends, how many classes does she have altogether? So there are 38 classes. So 69% of 38 is the number of times she comes to class on time. So I'm going to go ahead and use my class calc here. Da, 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 da. So here is my class calc. I'm going to go ahead. It is 69%, which is 0.69. 0.69 times the number of classes is 38. And you see 26.22. So I'm going to go ahead and write that down, 26.22. There you go, 26.22, but we're rounding off, so I'm going to round it off to the next decimal, which is 27. Because she can't come 0.22 times. That's impossible. So you always round up when it comes to cases like this. Let's go ahead and take a look at the next one. The probability that Jessica is on time for a given class is 64%. Okay, so 64% of the time, Jessica comes to class on time. If there are 53 classes during the semester, so if there are 53 classes during the semester, what is the best estimate of the number of times out of 53 that Jessica is on time to class? Again, I'm trying to find 64% of 53, rounding off to the nearest decimal. Let's go ahead and plug this into our class calc. Da, 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 da. There we go. I'm going to erase this one. 64% in decimal is 0.64 times 53. So it's 33.92. So let me go ahead and write that. It is 33.92 rounding off. So she comes to class 34 times on time. Okay, so your entire section is based on these two type of problems. And if you have any questions, contact me through Teams or email me. Good luck.